Good morning, people. I got a comment on one of my videos. It's the one where I show that I fixed the ripples or waves on my prints. The comment was pretty straightforward. I actually thought I covered it in the video, but I didn't. So let me just read you the comment. Hi, can you explain the flow? Actually, he said, "Hi, can you explain flow and which settings you are referring to in the slicer?" So I reviewed my video and I realized I didn't actually show you guys that in the slicer, from what I can tell. I talked a lot about it, but I didn't show it. So I'm gonna try as best as I can from a newbie perspective to explain it to other newbies. Hopefully you will understand it. I will show you in both Bambu Studio and Orca Slicer. And let's just dive into it by starting to make a project. So this is Bambu Studio, and you have several things that are in correlation to each other. And let's start with extrusion. Extrusion is when the extruder in the printer is pulling filament from the source, and then it's pushing it into the hot end. And then you have the physical melting of the filament happening in the hot end. And then you have the pressure used to squeeze the filament out. And that is, as far as I understand it correctly, the flow rate. But you have also something called max volumetric speed, which is the power used to affect the flow rate. And different filaments have different kinds of power based on how fast it can melt. And if you are pushing it into the hot end faster than it can actually melt, then you will get a buildup of melted filament going up to the top, and it can cause those nasty blobs you can see on some videos or posts online. I realized that when I actually saw that happening to one of mine, when I tried to use a too high value of volumetric speed pressure for white filament, and then that filament started squeezing out on between the hot end and the extruder, where the cutter usually go. And then I started calibrating that, and I fixed that issue. Now, to address the big question, what is flow rate? So flow rate basically is when you print, your nozzle will have a certain amount of filament based on the nozzle size that it will squeeze out. And you adjust the height of the build plate to be as perfect as possible based on the pressure you have for the filament that goes down, so that when you put down a line, it will not be too high and have low grip, and it will not be too close and have bad grip. So the set height is important to have a good laydown of the filament. Now, the flow rate is important because if you it usually has a value of 1. I can show you here in the this is Bambu Studio that you see here, and you go into your setting here for the filament. You can select edit. Now on Bambu printers you can use Bambu filament, and these have like an RFID which will be read, and the flow rate and everything will sort of be automatically applied when you print. If you want that, you can turn those off though. Now inside the filament settings, where I am now, under the filament, you have something called flow ratio. And that is something you can calibrate under here, calibration. So the flow rate for most filaments is set to 0.98. That means that it is at 0.98%. So if you set that to 1 here, which is what I'm talking about in my previous video, then you are basically having a 1-to-1 ratio. So the maximum amount of filament you can push out is attempted to be pushed out at that flow rate. The problem is that most filaments do not behave properly when you use a flow rate higher than 1, because if you want to use ironing, for instance, ironing would typically try to get as close to 1 as possible without creating ripples and waves. Because what happens is that, let's say you put down your filament and then you're printing and it goes forward, but you have too high flow rate, so the filament is pushed out a lot, and then the nozzle itself is getting filaments pushed out on the sides, and it will basically be pushing the filament in front of itself, and you get these ripples and waves, and it just looks horrible. So as a standard, start with 0.98, as you saw the filament had here as a value. Now, if you run a calibration, you should use 0.98 as a baseline for that calibration, and then it will try to adjust it upwards and downwards in the calibration settings. In my video, I told you that I discovered that any filament I have at least fails and give ripple patterns if I use a flow rate that's 1 or higher. That's not the same as saying you should never use it, because there are some weird filament out there that actually could require a bit more flow rate to give adequate prints. But for me, I print mostly PLA and PETG, and when I started having these problems for over half a year, this is the final solution I came to, is that my value was like, it was set to like 1.050 or something like that, and this basically created, even from the first layer, it created ripples and patterns, and the prints were just horrible. So in Bambu Studio, it's here, and if you go to Orca Slicer, it looks like this, and you have it basically in the same settings, and on the filament, and then let's see where you have it. You have it here, flow ratio. Now you have something in Orca Slicer called pressure advanced. It's like when your printer is going to a corner, and then it needs to do a turn, and then needs to go back again. And to make sure that the line is perfectly symmetrical all the way around, it will try to dynamically adjust the pressure before it gets to the edge, and then turn and come back. And that is also what we call the K value. It's not actually directly the flow value, but you need to, for specific filaments that's not bamboo filament, for instance. That's myself. You have to also calibrate that. Otherwise, you will get like to a turn, and you will get a really thin string, or maybe a big blob of filament, and then it doesn't turn, depending on your filament. So start by calibrating your flow ratio as good as possible to get a good line in a straight line, and then you start with doing the pressure advanced calibrations. Now, I do not know if Bambu Studio still has this. I'm checking here. I think it has it here, but you have to add here, adaptive volumetric speed. I don't know if that is the same thing. Let's see, advanced settings. I don't use Bambu Studio that much. Maybe there's a setting for it, but I use Orca Slicer for most time, and I have to manually set it. And I can show you an example. Give me a second. So here is Orca Slicer, and I have some filaments I calibrated. And here you can see I have calibrated the flow value to be 0.957 for this white filament, and it has a pressure advance of 0.06. Now, a lot of filaments have a pressure advance of 0.04, especially the bamboo ones, and you can sometimes see that in the display on the printer. It says K 0.04 or something like that. So in this case, for this filament, it will print, and then will come to a turn, and it will do an adjustment in pressure of 0.06 before it sort of continues the turn, makes the turn and go back, and then it drops that pressure again and it continues. So basically what you get then is you get a perfectly symmetrical line even in the turn. And that is basically what the pressure advance do. And it is important to calibrate that. Otherwise your prints will look really, really weird in the places where it's supposed to connect to the walls. So the walls will look like it has gaps like this, because the pressure advance normally makes sure that the lines are symmetrical even when you do the turns and go back without over pressuring the filament. And the thing is, if you want to use ironing, you never ever should be above 1. At least my experience is that if you're above 1, what you will end up with then is that it already has max flow of the filament onto your print, and then you try to iron over the ridges you already created, and you just enhance the ridges, and thus you get all these weird patterns. So usually you can see if you have this pattern problem, this pressure this flow ratio problem. You could see that already on the first layer. But if the problem is only in the corners, this could also be that the print is warping on the sides. But if the problem is symmetrical or several places throughout the print, in the middle of the print, then it's a flow issue. You're using most likely too high a flow value. Now, I'm not saying it's 1. It can also happen lower than that. So let's say my filament is set to what I have here, 0.957, and that's what I set it to. But the best print flow value for this filament would be 0.94. Then I could get patterns as well, because I am using too high a flow for that filament. Okay, so that's why it's important to do the calibration settings. Now, in my experience, the calibration tool is horrible when it comes to PETG, because at least the PETG I use requires a very slow printing. And the calibration tools, they will just run at a default speed for all kind of calibrations, and that can totally mess up your prints, because you get the wrong flow value calibrated compared to when you slow down the speed. When you slow down the speed of a print, you give it more time to push out filament, and sometimes you can actually compensate for flow by increasing the speed. I had a problem where I get like tiny dots that get put down because it cannot let's say the filament is oozing a tiny bit, and then it gets put down and it starts printing, and then you get the problem. Yeah, let's see what was more that he said. So I talked about a little bit about what the flow is, and it is important to calibrate it. And most of the printer manufacturers, they have their own websites or wiki pages that explain flow values, and there is a lot of flow values online, and you can search on YouTube as well. The thing with 3D printing is you need to spend some time researching to do this. Now I'm going to tell you another thing. The most important thing about filament and slicers is that you need to save your filament profiles. Like for instance here I have in Orca Slicer, I have saved these filament profiles. Let me see, I have this open, I need to close that. So you can see here I have several filament profiles I saved myself, trying to calibrate this. And like here, the yellow one has a different flow rate, because it's a gold one, it's a gold silk gold filament, and has a different print temperature set for when printing. Like this is the printing in the first layer and other layers, and you also have to set the bed temperature, and you can save all the settings with that specific filament, so that if you want to reuse it for a different print, then you can reload that profile and use the filament without having to reconfigure the flow rate for the filament every single time. And that is really great. Now I did mention max volumetric speed, which is the pressure you put down the filament into the extruder so it melts. And if that, imagine it like you have a dam of water, and you have this big, what do you call it? I had to look it up. Dam locks. It's like big ports you can open, and the nozzle size is the port size. And in printing a plastic filament, it's not the same as water, so, which has a bigger viscosity, so it just goes out. The filament, when it melts, it has to go somewhere. So in my case, this gold filament has a max volumetric speed flow of 3.96 millimeter. What is it? Not square. It's volume. It's the volume per second. So it's 3.96 millimeters per second. Volume pressure. I don't know the English word for it in my head right now. And that's for my 0.2 nozzle. For my 0.4 nozzle, that would be a lot higher, like 12. Basically, the nozzle size is bigger, so it can push more filament out. But this value, max volumetric speed, is directly linked to the speed you print at. And I'm going to show you my other one here, which is kind of funky. This white filament is kind of weird. 0.2 nozzle. And I actually overset it here. The max speed this filament can print with is 23 millimeters per second. 23 ms per second. And that is directly based on the value of the max volumetric speed. Now I had to increase it a little bit to give it some headroom, but if I make this too big, it will basically be hard to get good results, because the flow rate will be like having the dams full open and there's too much water coming, and it cannot basically adjust the speed when it comes to the edges, and you get over extrusion, and you cannot adjust the speed when it's printing, like in circles, you get over extrusion. So max volumetric speed is really important to also try to figure out for your filament. Usually the profiles you have is based on your nozzle size, so it's usually okay. But if you're struggling with your filament, try to reduce your speed of the filament. And even though the max volumetric speed is set high, it would not then print faster or higher than the max volumetric speed setting, or the speed you're actually printing at. But imagine it being like putting the brakes on a car, and you're not fully braking, but you are sort of you're holding your foot on the brake going downhill, sort of. But you still want to get there, so you don't fully brake, you just keep it a little bit on it. So that's like volumetric speed. You give it a max value, and the printer will try to, or the slicer will try to follow that value. Okay, some filaments, like white for instance, in my experience, they require a little bit of hotter printing temperatures. So I think the black is, I think the gold is 210. Yeah, my gold is 210. And even though it's a silk filament, it actually prints well at 210. And the white one, I don't get as good prints when I go lower than that. Yeah. So I think I covered the things that, let's see, what was it called? I can do a shout out. Solid Slug 123 gave me that comment. So I will just like to say thanks for watching, and thanks for commenting on my videos, and in that way requesting new contents and clarifications and everything. So I've had a lot of negative and positive feedback on that video specific for fixed wave ripple patterns in your prints. For some users it will help. For other people, they will just tell me to that it's just BS and go hide. But I did test everything. If you load that video in a web browser on your PC and you just look at the illustration photo in the start, you will see how many weird things I actually tried to test to get to that goal. I actually did calibrations, but those calibrations were wrong. So yeah, thanks for watching, and I hope to see you in the next one.